All right, hello all. I hope we're excited to learn some calculus today. Today we're going to be looking at how we can find the limits of functions using graphs and tables. We'll talk a little bit more about what a limit means in a minute. But to start with, go ahead and try this warm-up problem. A rock breaks loose from the top of a tall cliff. The table gives the number of feet fallen, so how far has the rock fallen at different times. So after 1 second, the rock has fallen 16 feet. After 2 seconds, the rock has fallen 64 feet. After 3 seconds, it's fallen 144 feet. And after 4 seconds, the rock has fallen 256 feet. So using only this data in the table, about how fast is the rock falling, not how far is it fallen, how fast is it falling at 3 seconds. Go ahead and try to answer that on your own. I will tell you in advance that this is a question that over the years students have struggled with, even though technically it's an Algebra 1 problem. Okay, so hopefully to find about how fast the rock was falling, you looked at around 3 seconds. How far did it fall near 3 seconds? So from 3 to 4 seconds, I can see that the rock fell 256 minus 144 feet, which is 112. You're welcome to use a calculator on stuff like this. So it fell 112 feet. This is how far it fell. And it took it 1 second to fall that far. So it fell 112 feet in 1 second. So it fell 112 feet per second. Okay, that's one possible estimate. There are 2 other possible estimates that are also fine. We could have looked at how far the rock fell between 2 and 3 seconds. So we could say, well, the rock fell, how far did, well, if it had fallen 64 feet and then it had fallen 144 feet, the distance it fell was 144 minus 64, which is it fell 80 feet. And this is feet. It fell 80 feet. In how many seconds? Well, 3 minus 2 is 1 second. And so we get that the rock fell 80 feet per second over that second. And so this is an estimate for the speed the rock is falling. Maybe the rock was falling 80 feet per second. Now, these aren't the same estimate as each other. Let's go ahead and get a symmetric estimate. We can also take the 2 points around 3. This is an acceptable estimate. We can say, look, okay, if I take the time from 2 to 4, I can get 256 minus 64. So this is, I'm looking at 2 seconds and 4 seconds. The rock fell an additional, oh my goodness, what is this? 192? Is that right? Looks right to me. Divided by, so it fell 192 feet in 2 seconds. So it fell 192 feet in 2 seconds, and so the speed it was falling was 96 feet per second. All 3 of these are considered correct estimates in calculus. I'm sorry, that was off the screen for a second. The rock fell 192 feet in 2 seconds between t equals 2 and t equals 4, and so it was falling about 96 feet per second. These are speeds. Notice it has feet per second. These are units of speed. We should be familiar with that, I hope, from science. But this is how fast the rock was falling. And these are 3 estimates. Now, what you're going to want to do is think about last class. If we have this additional information, and this is correct, that the distance is measured by 16 t squared, which is actually how fast rocks fall if you drop them. This is like completely accurate. We want to give a more accurate estimate for how fast the rock was falling at 3 feet, because we had these 3 very different estimates. We want to get an accurate estimate using our skills from our first lesson. How can we find out how fast the rock was falling at t equals 3 seconds? Go ahead and try to answer that on your own. And you may have struggled to apply the knowledge that we had from our last class, but let's try to do it now. The idea from last class was, well, we don't need to wait until 4 seconds. That's pretty far away. What if we took 3 seconds, which is the rock had fallen 144 feet, and we take another point that's very close by, like 3.001, and we need to calculate how far the rock has fallen using the equation, which, I need a calculator for. And I don't have a calculator, so you're gonna need to wait just a second while I go find a calculator. So there it is. Great, I found a calculator. And you may need a calculator like Desmos, or maybe one that's downloaded onto your phone to do this. So I can't do it without a calculator. So we're gonna do 16 times 3.001 squared. And we can see that the rock fell about 144.096 feet. And when I do y2 minus y1, I find how far it fell and how many seconds. It fell 144.096 minus 144 feet. And I'm going to use this exact number, though, in my calculator. So it fell this many feet in this many, so that's how many feet it fell. In this many seconds, only 0.001 seconds passed. And so this will be 0.096 divided by 0.001. And when I divide, and I'm going to use this exact answer, this number divided by 0.001, we should get 96.016. And so this looks like about 96 feet per second. And in fact, if we chose a number even closer, we would see it would get closer and closer to 96 feet per second, which was one of our estimates. It turns out this estimate is actually the right amount that it was falling at 3 seconds, the exact amount. So let's talk about what we're going to be doing today. We have this idea from last class, from our first lesson of the year, that if we get closer and closer and closer to something, we can get a better estimate of how fast it's changing. And I really want to point out that this warm-up shows the difference between, this is like algebra, and what we're looking at here is calculus, because we're looking at the rate of change. This rock is falling faster and faster and faster, and we're looking for how fast is it changing right here. And so our idea is that if we get two points very close together, that can give us a very good estimate. And we're going to bring in the concept of limits. And I'm not sure how far you guys got in your pre-calculus class last year. Hopefully you got somewhat far on limits. We talked about them a little bit in Algebra 2, but we're going to talk about them tremendously more. That's my dog barking. We're going to talk about them way more this year in calculus. And so let's make sure we're all on the same page about limits. This is how we write a limit. You'll see limit with a variable with an arrow going towards a number of some function. And the way we read it is the limit of f of x as x approaches 2. And what this means is approaches means gets close to. And so this means that as x gets closer to 2, is the y value going towards some limiting value? So is there a y value that it's getting closer and closer to but will never quite reach as you get closer and closer to it? So here's an example we might look at is when x is 1.9, the y value is negative 4.8. When x is 1.99, the y value is negative 4.98. When x is 1.999, the y value is negative 4.99998. And so this is the limit of the y value. We might want to ask, what is the limiting value of the y value as x gets closer to 2? I hope you guys can see that this is as x is getting closer to 2, but hasn't quite gotten there. Is there some limiting y value that we're getting close to? So, is there? And hopefully we can see that this is getting very close to negative 5. Negative 5 seems to be the limiting y value. As x gets closer to 2, the y value is getting closer to negative 5. And we will use this a lot. It turns out there are a lot of situations where you can't actually do something right there. Like in our first lesson, we can't pick a point that's right on top of itself. Like if I have a point like 3, 5, I can't also use the point 3, 5 to find the slope. I can't actually have a point that's directly on top, because if I tried to do that, I would do y2 minus y1. Oh my gosh, guys, you couldn't see that. I'm so sorry. In our lesson from last class, we talked about how we want to get 2 points close together, but we're not actually allowed to use points that are right on top of each other, because if we have 2 points that are exactly the same and we try to do the slope, we'll do y2 minus y1 divided by x2 minus x1, and we'll get 0 divided by 0, which is undefined. And so we don't actually know the slope between a point and itself. That doesn't make any sense. Instead, our idea is to get closer and closer and closer together, and that's kind of what we were doing in our first class. And the math idea for what that is we're finding the limiting value as 2 points get very close to each other. Another time we'll end up using limits this year is what happens as something is going towards infinity. So infinity isn't something you're ever going to get to. So a lot of times we'll do the limit as x gets closer towards infinity, which means x goes to 10 and then 100 and then 1,000,000 and then 1,000,000,000, and it keeps getting bigger and bigger. What is happening to the y value as x gets bigger? So that's where we'll be using limits. Let's explore how to do them in graphs and tables today. We'll move on to equations pretty soon.